and it is going. How nice. I'm TigerHawk3, and it's about 30 seconds to midnight. Yay! I was doing other things yesterday. I was playing Star Trek Online. I was playing more today. Yesterday I was streaming it. I was playing more today, and there was much stuff to do. It is currently a dilithium weekend, which means when you grind MMO tasks, you get more stuff from it. So I've been doing that. It sounds foolish because it is, but I was doing it anyway. Let's see. Collections is what we're doing. I think we got to. Let's see where we are. Max line. We got to deck last time, so we're going to look at default dict. This is a cool one, so let's do that. First we gotta import collections. That's important. Default dict. What this does is it's a type of dictionary, but it has some convenient convenient extra behaviors that basically allows you to have default values. And notice how the now you can notice how it's a lowercase everything, whereas counter started with a capital letter, and we'll see later that order dict, which is another kind of dictionary, starts with is camel case with capital O and D. So that's fun. But it's very useful. So ordinarily, let's say we are let's say we don't know that counter exists, which many people don't. So we'll have a dictionary to hold the counts of each object. So we will have data equals how about 2 of these and 1 of those? Sure, I don't care. And 4 of those and 3 of those. I don't know. So we will have a dictionary. Funny story about these open and closed curly braces for a dictionary literal. The dictionary literal came about, wasn't always there. Not everything in Python has always been here. At the point this was made, this seemed like a good idea at the time. But to make a set, what do you think a set is? A set would be like 1, 2, 3. And a dictionary is, you know, something else with attached values, right? So this is an empty dictionary. That's not helpful. See? How about a set? That would be this. And notice how the repro is just the constructor. That's because there's no literal. They made a literal for dictionaries, and then it's like, well, what are we going to do for sets? I don't know. What we have for dictionary would have been good. So now they kind of wish that they'd done this for an empty set. I mean, there is a set literal, but not an empty one. So they kind of would have liked to change this to be an empty set and this to be an empty dictionary. Wouldn't that have made sense? But it's not like that. Sorry, maybe in Python 4. So let's say we have d equals counts. No, counts equals an empty dictionary. And then we'll say for letter, here's what I like doing. For datum in data, it's extremely accurate and totally useless as a name. For datum in data, here's what we have to do. One option anyway. If datum in counts counts datum plus equal 1. What did I do? Oh, whoops. Wrong. Pressed shift too eagerly. There. Else, counts datum equals 1. Alright. So what this does is, we scroll down, we go through each letter in our string, the datum in data, and if that letter is found in this dictionary that we have, then we access it and set it to a new value of whatever it currently is plus 1, and if it's not in there, we set it to 1. And let's see what counts is. It seems quite reasonable, because of course. Now we can streamline this slightly with the get method. Let's clear that again for this and what's it. Now instead of doing this, we will do counts.get datum and 0. No, counts datum plus equals counts.get datum and 0. Is that right? No, it is not. What's this? Plus 1. There we go. Now let's check counts again, and lo and behold, it is correct. So what this does instead is we always just set it to the new value, but instead of checking whether it's in there, we use the get method, which attempts to retrieve the datum we're looking up, and if it doesn't find it, the second argument is a default value. So if you can't find it in there, just say it's 0, and so it's either either 0 if it's not there, or whatever the value is, if it is, plus 1, because that's what we're doing. We're counting by 1. So there's one way to do it. And now another way to do it is to say counts equals collections.default dict. And here's where the magic is going to happen. We're going to pass it a function that, when called, produces the default value that we would like each entry in the dictionary to have. So if we look it up, or if we look up a key and it's not in there, it will return this value. It will create and return this value. So we're going to do int, because the int function, when you just call it by itself, returns 0. And that's what we want. We could also do lambda 0. But this is preferred. And we will do that. For datum in data, counts datum plus equal 1. Now let's look at counts, and we'll say that it's a default dict, indeed, of class int. That int is what it does if it doesn't find anything. Then we have a being 2, and e being 4, and z 1, and h 3. So what this does, we don't have to use get, and we don't have to do a membership check. We just look it up, or first we will, this is, counts datum equals counts datum plus 1. So first we look it up, and since this is a default dict and not an ordinary dictionary, if the key's not in there, it won't produce a key error. It'll just give us our default value of calling the int constructor, which is 0. And then it adds 1, and if it did exist, then it'll be whatever it was. And we add 1, and we reassign that back to its proper place. And then, of course, we would just say, counter. That's faster still, because that's what we're actually doing. But when would we not want counter? Here's an even better use case. Let's say, what are we keeping track of? How about we have a classroom of students? A lot of the examples in programming end up being there's a class with students, because what is the one thing that a teacher knows for a fact that the students are familiar with? Being in a classroom, because they're there right now. Makes things kind of bland, I guess, but it's better than saying sometimes there's these standardized tests that are like, if they want to test a child's knowledge of arithmetic, for example. If Johnny gets 2 gifts on each day of Christmas, how many gifts will he have? And the test taker must know that there are, 12 days of Christmas, only not really, it's only 1. But it says 12, I don't know. And then they would have to already know that. That is a very drastic example. But there's lots of more subtle ones. And everything being classrooms handily avoids that. So let's say we have a classroom of students, and our students are Alice, Bob, and Charlie, whose names are conveniently sortable by the first letter. And let's say they have taken tests. There are 3 tests in the class, and each student takes all 3 tests. That's great. But what does it matter? It matters because we're going to use a default dictionary. So test results equals collections.default dict. And now we will use a list. And the list constructor returns an empty list. That's what we're going to do. Let's actually do this with a regular dictionary first. And then we can, work with that and see what we have to do, and then how will it be different with a default dict. So let's make some data equals here's what we will do. Alice, let's pretend we have a text file containing these things. Um, 90 this. And Alice, actually let's say Bob, 90 something, and Charlie got an 80 what's it, just to be different, and then Alice got, this test was harder, and Bob got an 87, and Charlie got an 81, and for the last test, which was extra hard, Alice got a 91, and Bob got an 85, and Charlie studied, so he got an 89. He's very happy with that. All right. Cool. So this is more or less a text file-ish, only it's a string. But that's cool. We can work with that. So let's say we have our test results, empty dictionary up here. For line in data.splitlines, and this splits a string on new lines. We could have just done actually split. It doesn't really matter. But if we had like spaces and tabs in there, let's just do split lines. That's better. Yeah. Split lines. It would technically work with split in this particular case, but it would be a fragile solution, so we won't do that. For line in data.splitlines, name score equals line.split on colon. Score equals int of the score. Very good. Now if name in test results test results name dot append score else test results name equals score. All right. And now let's look at test results. Would you look at that? Very beautiful. So what we did here is we went through each line in our text file that isn't really a text file. Can you see the fingers? I have to put them close together. Text file. And we unpacked, we split the line on the colon, and we unpacked that into a name and a score. Then we turned the score into an integer. Not totally necessary here, but if you wanted to do more stuff with it, like find out the average, etc., then it would be important. And here's the part that we're going to solve with the default dict. So pay attention. If the name that we found in this line is already in the dictionary, then let's look at the else case. If it's not in the dictionary, we're going to create a new key in the dictionary with this name and assign to it a list with a single value of this score. And if it is in the list, or sorry, if it is in the dictionary, we assume that we already have a list, and we're going to access that list, which is this key's value, and append the current score to it. And that gives us what we want. Alice having 96, 92, 91, and Bob also going down, and Charlie going down and then back up. So that's great. But what if we didn't want to do this whole testing thing, right? Test results equals collections.defaultDict. And we're going to pass an argument of the list function. What is the list function? It is also the class list, and if we call it, we get an empty list. That's it. So remember, this is the function that we're passing as an argument, and when we look up a key that isn't found, it will call this function and produce whatever value that function returns. So we have our test results, and now for each line in here, we're going to split it up and make an integer. And now test results name dot append score. Notice how we have this line here, which is if the name is present, then we can access it and append to it, right? But we're not checking for membership. So when we do this, if it does exist, it will, retrieve the pre-existing list. But if it doesn't, it will create an empty list and set the value to that, and then it will append the score. So let's do that. And now let's look at what we have for test results. It is a, oh dear. What does this do? Same thing. Okay. Forward in string of this. String of this dot split print word. Okay. All right. That's the workaround for something that extends almost twice as far to the right, as we can see. So we have default dict, and the class that it's doing is a list. And so we have Charlie, and these are his 3 scores, and we have Alice, and these are her 3 scores, and we have Bob, and these are his 3 scores. It's the same thing, pretty much, as a regular dictionary, only has a couple extra handy things. Like, if something isn't found, you can do anything. You could, as I briefly showed earlier, you can make a default dict with a lambda function instead of a built-in. And then you can have anything you want. It can even be a traditionally defined function with very complex stuff. And side effects if you really want. And when you call it, it will do whatever you told it to do and return a value. Can we do none? Can we do that? Lambda none? Can we do that? I wonder. We can, maybe. Well, it's lambda. I don't know if it will complain. There's no key of 3, so it will return none, and printed none. Let's call it n for none equals this, n 3 equals string of dot format. This is called a contrived example. Format n3 and 3 or something. I don't know. And what does n have? This is the anonymous function that we gave it. And we have 3 being a string of none, which was what it looked up, and 3. Oh, this is the... right, it's the value, not the key. I wonder if none is hashable. It is. So there you go. I don't know what the purpose of that was, but anyway, default dict allows some very handy things, so that you don't have to check whether something exists already in the list, in the dictionary, and just create it whenever necessary. It's pretty handy. One of these. This is simpler and faster than using Setdefault. Dictionaries have a method called Setdefault that allows you to set a default value. And so you can, it's basically get, only it sets the, like, I can show you why not. D dot set default 3 md what's it dot append 4, and what's d? 3 with a list of 4. So what this does is basically, instead of get here, we're still looking up, if we had get, it would look up 3, and if it's not there, it would return this. But Setdefault immediately creates this key, if necessary. So it has already been created and returned, and then we can append the value we want. So we appended that to the list. But default dict is generally better, because it's clear what kind of dictionary exactly we're using. That it's one that every time, if we don't have, if we can't find a key in it, we will create a default one. What else have we got? Lambda, etc. What? A constant factory. Interesting. Okay, what else have we got? Named tuple and order dict. I will go through named tuple briefly, I think. I don't think it's quite as amazing as default dict. It's sort of like a regular object in a user-defined class, only also similar to a tuple. So options.named tuple returns a new tuple subclass. Oh, it allows us to subclass tuple and name it. My tuple, I don't know. Field names, let's see. The field names are a single string with each field name separated by white space and or commas, or a sequence of strings. Any valid identifier may be used except for names starting with an underscore. Let's see what this actually does, what it is. Name tuple instances do not have per instance dictionaries, so they are lightweight and require no more memory than regular tuples. They're a kind of small and fast version of objects. I see. So we'll have a mytuple with about name and age. Let's make this person with name and age, because it can be a white space separated string that's basically just split on white space, or you can pass it like a list of strings. Name and age. Is that it? Pretty much. That's all I need, I think. What's T? Okay. Is a class of person, but it's more lightweight. Okay. T dot name equals Alice. T dot name equals T dot age equals 23. Now what's T? T dot name is that, and T dot age 23. So it's a tuple that allows dot notation for attribute access. So it's okay, I guess. I've never actually wanted to use it. This is the first time I've ever tried it. I don't quite see the point. Maybe if you need more performance over objects, could be good. If you have objects that are pretty simple, I mean, over objects, over user-defined classes. So if you have simple stuff, but like a lot of them, then you might want more performance, I guess. Generally, when I make a class, it's because they have specific behavior. Can we get behavior from these? I don't know. Name tuples are especially useful for assigning field names to result tuples returned by the CSV or SQLite modules. SQLite 3, I should say. For employ in name tuple of these. They have it with a comma as well? How strange. Oh, separated by white space and or commas. They can do everything tuples do, and 3 additional methods and 2 attributes. There's an underscore make, an underscore as dict, which turns it into a dictionary, an ordered dictionary, because tuples are ordered, and an underscore replace, returns a new instance of the name tuple replacing specified fields with new values. I don't really know how useful this is. So it's a class. You can add or change functionality with a subclass. You can do that. I don't know why you don't start with a regular class in the first place. Let's look at an order dict for a bit. Not too much. O equals collection. I always got to spell it wrong. Order dict. O3 equals 5. O1 equals 9, 8 equals 4, 0 equals 3. And now let's look it up. Notice how it's in the exact same order that we provided. 3 and 5, 3 and 5, then 1 and 9, 1 and 9, then 8 and 4, then 0 and 3. An ordered dict is an ordered dict. That's all it is. If you have a dictionary and you want to always go through it, iterate over it, I mean, in the same order in which you added items to it, you might want an ordered dict. Basically gives each item a separate key for ordering purposes. Can we do does this work? No. So you have to look them up by the key and not by the index. Maybe o.index, can we do this? Would be handy. What's the index of 8? Don't have an index. So it's sort of like, I guess it really only can be used in that way. You can't access them like a list. You have to access each key. I think it's F#, is it? That has data structures where you can refer to their elements by an index or a name, and you can name some of them. Is that F# or is that R? I don't even remember. But ordered dict is, I have a dictionary and I always want to iterate through it in the same order that I added things to it. That's what you do. New in 3.1, there's a method to pop the last key value pair and return it. And it's not called pop, it's called pop item. There's a move underscore to underscore end dot move to end. Which key? Let's say 1. Now let's look at O again. We have 3, 5, and then 8, 4. We skipped 1, 9, huh? And then 0, 3, and would you look at that? 1, 9 has been moved to the end. So it basically pops this one, removes it from the list, removes it from the dictionary, and then adds it. And it will be at the end. Pretty simple. Seems kind of like O dot, is there a pop? 8. No, I would have to save that. So let's say AB equals O dot pop 8. Oh. Okay. So it doesn't pop a pair. Pop item removes a pair. So basically this is A equals 8, B equals O dot pop A. What is it not in there? Oh, it's not in there. Oh, because it finished popping it and then failed to unpack it. Right. 08 equals 4. Let's look at O again. How about 0 and 3? Equals 0. B equals O dot pop A. OA equals B. And now let's look at O again. 0, 3 is at the end. So this is basically what move to end does. It removes a key and value from somewhere in the dictionary, from wherever you wanted, and adds it back. And it will be at the end. Reversed iteration using reversed. That's great. Equality tests between ordered dict objects are order sensitive. So if we have O O equals 1 equals collections dot this with that. And let's say 8, 4, we're moving 0, 3, 0, 3, and 8, 4. Okay. O and O1. So notice that they are the same, except for the last two are switched. And we do O equals O1, and that's false. So equality is one of the important parts. Note that we can do 1, 2, and 2, 3 is equal to 2, 3, and 1, 2. And that is true, because regular dictionaries don't care about the order. The order dict constructor and update method both accept keyword arguments, but their order is lost because Python's function call semantics pass in keyword arguments using a regular unordered dictionary. So if you do collections dot order dict, and notice how this is camel case, because of course it is. Dot order dict A equals 1, B equals, let's do F equals 3, B equals 2. And notice how we have B equals 2 for B and 2 at the beginning instead of the end, and then F and then A didn't maintain the order. That's because these are passed in using implementation detail, a regular dictionary, which may be iterated over in any order according to however the language works internally. Implementation detail. So don't rely on that. Okay. Since an ordered dictionary remembers insertion order, it can be used in conjunction with sorting to make a sorted dictionary. Okay. So you can sort a dictionary and save it into an ordered dict, and then you have saved that dictionary in an ordered manner. If you want to iterate over it in a sorted way many times, then just saving that order could be good. So that's something that you could do. The new sorted dictionaries maintain their sort order when entries are deleted. Makes sense. When new keys are added, the keys are appended to the end. Well, yeah. When the keys were last inserted, etc. Okay. So that's mostly it for ordered dict. If you have a dictionary and you want it to always be in a certain order, this is how you do it. And now there are a few more classes. User dict, user list, and user string. And I would say there's no point to these anymore, because all they are wrapper classes for dictionary, list, and string for those types. And we can already subclass those types directly. So not super much purpose to this. Could be good to use them, but data and data. The underlying string is accessible as an attribute. So before we could subclass the dictionary, list, and string types, we had these wrappers of user dict, user list, and user string, and now we can subclass them. So not incredibly useful, but maybe if you want to access the actual string, I guess it would be self ordinarily. I don't know. Class that simulates a string or a Unicode string object via the data attribute. Let's do that. Let's see. Collections.userDict. Now what's C? It's a dictionary. C.data is that. So it's sort of a subclass, but the actual dictionary is different. So, or actually, yeah. So it could be useful, I guess. C is a collections.userDict, but the data attribute of C is just a regular dictionary around which collections.userDict is a wrapper. And same thing for user list and user string. It's a wrapper with an attribute data, which is the reference for the actual thing that is wrapping. And that's, I think that's it for collections. So, that's cool. I guess that's the stream for today. Tomorrow will be a game of some kind, maybe Star Trek Online. That was popular yesterday. Popular meaning someone watched the stream and said they wanted to see more, so maybe I'll do that. And after that, I'm not too sure. Probably another module, or maybe some fun with the turtle module. I want to be. I've been thinking of making a module of my own for drawing letters in Turtle. Because there's a way to create text on the Turtle canvas, but that just kind of plunks the text object there, and I want to like draw it with the turtle. So yeah, that is the stream for tonight. Tune in tomorrow for a game of some kind, and the day after that for either another module from Python standard library, or maybe stuff with Turtle. I don't know. So thanks for watching, and I will see you next time. Have a good one.